Hello, this is Susan Poss at Spartanburg Community College. I am working in Chapter 8 on solving systems of equations, and there are several techniques for solving systems of equations. One is to solve by graphing, which I think is one of the more challenging ways to solve a system of equations. We're also going to learn how to solve algebraically in the next section. We'll use something called substitution, and there will be another technique called addition/elimination that we will use. And when you get on into a college algebra class, you'll be looking at matrices to solve systems of equations. So what is a system of equations? What we're going to be looking at in this course is a system of two equations that each contain one or two variables. You can move on, and you'll be, in your higher level math courses, you might be solving a system of 4 equations and 4 variables. So it allows you to work with many different unknowns in the process. All right, so here are some examples of systems of linear equations. You can see in each case I have 2 equations. Most of them have both the variable x and y. You can, however, just have one variable in the equation. The important notation that will help you to realize that you are in a system is this brace that you will see out here in front. And of course, the purpose of that brace is to indicate that these are to be solved simultaneously. And that's what you'll see me doing throughout this whole chapter here, using different techniques. All right, so the first exercise that we go through here is to give you a solution, and these solutions are going to be in terms of ordered pairs. It's going to be an XY solution. So we'll be looking at, to begin with, you'll be given an ordered pair, and you'll be asked to determine if that ordered pair is a solution. So in each of these we're going to be looking for 2 answers, an X answer and a Y answer. And in these first ones you're going to be given the solution, the X and the Y. And what we're going to be doing is substituting in for X and Y, run through the arithmetic, and see if that pair of numbers, X and Y, balances both equations. If it does, we will say that it is a solution. So here's our first example, is an ordered pair with an X coordinate of 3 and a Y coordinate of -2. And you can see that I have taken this system and I've numbered these, equation number 1 and equation number 2. So on the left, I'm going to go in to equation number 1, create a little placeholder for X and for Y, and then I'm going to substitute in the 3 for the X and the -2 for the Y. And at this point, here's my left side, right side. I'm going to do the arithmetic. And it looks like this first one balances. Okay, so that's not enough for me to say that this is a solution of the system. That tells me that is a solution for that first equation. So now I need to go into the second equation, create these little placeholders for X and Y, substitute in the value 3 for X and the -2 value for Y, and then do the arithmetic. And you can see that -3 does not equal +4. So even though the solution 3, -2 was a solution for the first equation, it is not a solution for the second equation. Therefore, this is not a solution for the system for both equations at the same time. So that's pretty simple. I'm going to do one more quickly like that. I don't think you need to see any more than just a couple of these. So here's another one where it has given me Another solution, -4 is the x value, 1 is the y value. You see I've numbered my equations. I've written them down here. And I'm going to go out now and create these placeholders using parentheses. And into the position for x, I will put -4, and into the position for y, I will put 1. Now I'm going to do the arithmetic. Here's the left side, right side. So it looks like in the first equation, I've got a balanced set. Let's go also check it in the second equation. Check that solution for -4, 1. Here's the left side, right side, so I need to see a -8 here, a +9 there. And that's 1 and 1 equals 1, so it balances. So I would say yes, this -4, 1 is a solution for this system. That means, again, both equations are satisfied by that. All right, so that's where I'm going to stop there, and we're going to come back in just a minute and work on some graphing to find this solution. Instead of being given the solution, -4, 1, we're going to be looking for that.